Good day, citizens of the tech world. Don't you feel sometimes that the cost of testing on AWS can be quite prohibitive? I mean, a lot of us build a lot of applications that are now native to the cloud. And that is sometimes quite tricky to test, and cost being one of the factors. Well, personally, I like to test local, I like to test fast, and with AWS, if at anyhow means possible, I would like to do that as well. Now, what I'm going to run through is a couple of quick technologies that I think it's useful to be aware of, and I'll tie them in together to actually show you that you can do a lot of this local and actually save a lot of time and money at whilst testing for AWS applications. The first tech that you really should know of is something called LocalStack. There are two versions of it. The one is a pro version and the other one is the open source version. You can get quite far with the open source version as it supports a lot of the common AWS products we are aware of, like S3, SNS, SQS, DynamoDB. If there are some of those things that are not on there that's supporting the pro version, maybe you want to actually do that. But I think you can get quite far with just starting and exploring the open source version first and using it. Installing it is relatively easy. All you have to do is either pip, if you're a Python person, to install it and start it, or as I prefer to run it, it's in Docker, because it means it's a lot less things I have to install. And I like to keep my machines as clean as possible. It also helps when I want to run things in CI. And once it's running, you will actually have a very decent AWS testing environment running locally, which you can now point your applications against. The only problem yet so far is, how do I load my infrastructure onto LocalStack? Now, normally there are a couple of tools which allows you to build infrastructure and which treats infrastructure as code, which is another important point. Typically in the AWS environment, two tools are very popular. One is the native AWS tool itself called CloudFormation, and the other is Terraform. I would like to focus on Terraform for this. You can obviously use CloudFormation if that is more to your liking. And Terraform also actually allows us to configure a whole bunch of other cloud offerings, and that is one of the reasons why I like it. It also has its own language called ACL, which you can configure all of the resources for cloud in it. But there are a couple of additional offerings nowadays that allows you to generate ACL from DSLs in Java, Ruby, or JavaScript. Now, Terraform to be installed is very easy. Just download a single binary for the OS that you are working on. And if you now have LocalStack running, the only other thing you have to tell it is to configure Terraform in a way that it actually talks to LocalStack and not to AWS. It's pretty simple. You just have to reconfigure the endpoints in one of your TF files, and you can then just set up the port that LocalStack runs on, and include anything else that you need to fire up in your infrastructure. For instance, you want to create SQS, add a Terraform files for that. Then just simply apply the Terraform, point it to LocalStack, and there you go. You will have infrastructure running in LocalStack, which mimics what you've got in AWS. And at this point, if the only thing you want to do is fire up some local infrastructure just to do some manual testing, this is where you can actually stop listening, because these two things already saves you time and money. However, for the rest of us that like to automate as much as possible, let me walk into the JVM world, because that's one of the very popular platforms for deploying in the cloud. And the next technology we want to use here is something called TestContainers. TestContainers basically build on everything I already told you. It is effectively a test library that you use typically with JUnit, and it allows you anything that you can run in Docker, you can basically run in TestContainers. And what you're going to do with TestContainers is fire up as tests. It will run your containers, and once the tests are all completed, these containers will pull down again. And once again, this is a time saving because you don't have to spin up a bunch of additional infrastructure, be it local or in the cloud, just to do some testing. And being local in your integration suite means it's probably also going to be a lot less bristle than to test accounts services that are running in the cloud. Now, you need a test framework to run test containers with, and it natively supports JUnit and a couple of other test frameworks. I am specifically going to focus on using Spock here because Spock runs on top of JUnit, but it gives you a much more expressive way of writing tests while still leveraging anything of JUnit below. And versions of Spock are compatible with 4 or 5, depending on which version of Spock you are running. So given all of that, we can just simply now write a test in Spock. We annotate it with a container called TestContainers. We create a container. In this case, there is a special class already defined called LocalStack container, which if you pull in TestContainers is one of your dependencies you will get. And you can simply write your test now. If the test starts up, a container will be created before the test starts, and when all of the tests have completed, that container will be shut down. But now you're going to ask me is, okay, you started the container, what about my infrastructure? We've done it with CloudFormation or Terraform before. How am I going to do it now if I run as a test? Well, simply, let's combine everything. We basically just write additional code in our tests. One, to create out the provider file that we need, which you already seen. And the second one is to simply then deploy all of my Terraform. All I really need to do is to tell my test suite where my local copy of Terraform is. Now, if you use something like Gradle, you can even use the Terraform plugin, which will provide you a Terraform that is bootstrapped into your build, so you don't have to install Terraform manually. And then you will just simply use that and point your tests at that. Once again, what will happen is your test will start up. It will create a container. It will write a Terraform provider file. It will then run Terraform. It will set up all of the infrastructure. Your tests are now ready to run against all of the infrastructure. And it is local. We are not paying money to AWS when we don't need to. The final thing that you now have to do once you get the setup done in whatever time it's going to take you, well, I'm sure after you spend your 27.3 hours setting this all up, you will be happy because it's going to save you so much time. Now, if we're going to look at applications, one last tip I want to leave you with is, if you're going to run applications such as that's written in Spring Boot or Rails or Micronaut, which uses a lot of dependency injection, and typically will use the AWS SDK, you need to tell it to not resolve credentials and regions in the normal way it would do via the SDK. And the way to do this is simply to inject a factory bean into your integration test suite, which is basically never runs when your application normally would run, but when you run your integration test suite, you put this bean in there. And all it has to do is basically create a very, very simple credential provider and a very simple region provider. If you set this up, you can now easily fire up all of your integration tests locally. It will run, it will fire up TestContainer, will fire up LocalStack, it will test all of your AWS applications. And the way you've now actually saved time means is that you actually now go to test things eventually in AWS, you have a lot less to worry about. The only things you're typically going to care about there is whether things like maybe CloudWatch triggers are triggering at the right time, and whether you have hooked everything together, and whether you've actually created the correct roles in AWS. The rest of the effort, you actually move down local. Your developers can do all of you want to test, and anybody write tests can actually work locally. Thank you, and I hope you enjoy the rest of this conference.